Good evening, sir. This is Shaki. I'm going to discussing about federated learning. Before going to discussing about the federated learning, let's see some outlines for the federated learning. We will discuss here the introduction about the federated learning. Then we'll discuss here the architecture overview of the federated learning. Then we'll discuss here types of the federated learning. Then we'll discuss here the what are the importance of federated learning. Then we'll discuss here privacy techniques for federated learning and what are the challenges and possible attacks for federated learning. Then finally we will conclude the topic. Here we will discuss a brief introduction about the federated learning. Actually, federated learning it is a new technology for artificial intelligence. It is originally proposed with Google in the 2017. The main aim of proposing the federated learning is to solve the problem of local model and training the updating in the mobile edge devices. Actually, federated learning it is a decentralized form of the machine learning technique. Federated learning it is a machine learning technique that trains the algorithms across the multiple decentralized devices or servers to holding the local sample data without exchanging them. Federated learning it is a privacy-preserving approach to train the global model at the central server level by collaborating with the wireless devices with each other to own the local training datasets. Federated learning it can allow the machine learning algorithm to gain the experience from the broad range of datasets located in different locations. The main goal of for design the federated learning is to carry out the efficient machine learning among the multiple participants, communicating nodes and the promise ensuring information and security for the data exchange, protecting the privacy for the personal data, ensuring for the compliance. And here we are discussing about the architecture overview of the federated learning. In this architecture, in the above architecture federated learning, here two edge nodes are two edge devices are there, one A one B. The two edge devices can extend their scenarios with multiple edge data owners. Suppose the edge A and edge B when trained with machine learning jointly, and their business system have relevant the data with respective users. Here coming to here we will discuss about the types of the architecture. We'll have some types for the types of the architecture for federated learning. We'll see first here centralized architecture. In centralized architecture, here we'll place for here in centralized architecture it is one single central node is placed here. Yeah, here in centralized architecture, one single central node will be there. That single central node it can responsible for communicating with all edge devices to aggregating the local model and deploying the global model. The model transmits with the architecture very smoothly, and the nodes is dedicated which can be modified with suitable customized needs. Whatever the customized needs, it will be suitable for modifying with that customized needs. And coming to hierarchical architecture, in hierarchical architecture, it will introduce for several regional coordinator nodes. The architecture it is being introduced for the solve many parts of the communication bottleneck problems. The communication bottleneck problem means it is a communication context related problem. It is the bottleneck problem is enough data handling capacity to accumulate the current volume of the. It is a problem of the enough data handling capacity accomplish the current volume of the data traffic. Coming to here regional architecture. The regional architecture have been, it is similar as the hierarchical architecture. The results of demonstrate this regional architecture is to avoid the influence of the center failure to increase the system robustness. For this purpose, we will propose the regional architecture will help to avoid the influence of the central node failure, and to increase it will increase the system robustness. Now here decentralized architecture. It is the main architecture. Decentralized federated learning system, it can contain the edge nodes compared to other three alternative architectures like decentralized architecture. It will move the aggregation function to edge devices. This system can minimize the problem to performance bottleneck. The system it will can minimize the problem of the performance bottleneck problems like we'll discussed previously. It will load gets the balance for all the nodes. This system has better autonomy. This system having the better autonomy to quick adapt the local environment changes. Whatever the changes occur in local environment, it will adapt very nice quickly. Then federated learning how it will works. Federated learning can revolve around the federated averaging algorithms like federated averaging called as federated average. It is a very first vanilla federated algorithm and it can formulated by Google. Why? Because of solving the federated learning with related problems. Since so many variants of the federated averaging algorithms are there, like Fed proxy called Fed prox, Fed uh, Fed matched averaging, like we called and Fed optimization we called as Fed opt, scaffold we called as sophisticated control averaging for federated learning. These are some different variants of federated averaging algorithm proposed for the solving the many types of problems. So how it will works means a subset of clients or devices is a randomly sampled. The server the server can broadcast the global model for each client. Then parallelly that clients can the stochastic the gradient descent it can stochastic that gradient descent on their data loss and send resulting model to server the aggregation. The server can update the global model for the average of these local models. This process will repeat till the n number of communication till the convergence will happen. Some types of federated learnings are there. First type is horizontal federated learning. In horizontal federated learning, it is the most widely used in the federated learning framework. It can design it for the datasets to client share the same feature space. The most famous example for this horizontal federated learning is Gboard, which calls as a Google keyboard for the Android. Each participant here new model can train other the own devices to sending the gradient to the server. Like here, one server is there, one server A is there. Accordingly, databases. So sending the encrypted gradients from the database to server here. Then in this server, it can securely aggregation happen in the securely in that server. Then it will returns the sending back that models updates whatever the updates happen in that server. It will return to the databases. Then like that updating will happens in the database. Like that in horizontal federated learning working. In that vertical federated learning, it is designed to for the where the data sets can share the samples, but it can differ in the feature space. A federated learning, a vertical federated learning can propose for the privacy preserving logical regression model. So here, some first of all, here we can encrypt the we can encrypt the ID align. We can encrypt the basically as the user ID alignment to confirm the common user from both companies A and B. System does not expose here the not overlap each other. Then here we have one collaborator C which can handle the homomorphic encryption. Homomorphic encryption means it is a form of encryption that the user can permits the user can permits to computate doing computations on the encrypted data without decrypting them. Federated transfer learning. Coming to here, federated transfer learning one of the case where the data sets differ not only in sample phase. It can recreate the transfer learning under the constraints of federated learning. Importance of the federated learning. Federated learning, it has a, one of the most paradigm for distributed machine learning. uh, it can uses it can facilitate to uses it can utilize the very sensitive data sets to distribute it among the large number of clients and by mobile phones, other mobile devices, sensor without the collecting their data. In federated learning, it can train the global model subsets of the user instructed to upload their parameters to each synchronization. To update the global model, the centralized server is adapted here for aggregate the parameters received from the users and sent back to the global model to update it that global model to them. Some privacy techniques are there in the federated learning, that is secure multi-party computation. Secure multi-party computation is provide here providing a secure proof as well defined simulation framework that guarantee for zero knowledge. Each party knows nothing its input and output. Then second one is differential privacy. Here we can maximize the accuracy and minimize in differential privacy. In differential privacy it can maximize accuracy and minimize the opportunity to recognizing the individual by handling noise and regeneration that methods. And one more privacy technique is homomorphic encryption. Homomorphic encryption nothing but here user can permit to do the here user can permit to do the performance on computation, do the performs the computations on the encrypted data without decrypting it. Some challenges are there in federated learning. Four challenges are there. First challenge is expensive communication. So federated learning, it is a potential for a massive number of devices. Like for example, millions of smartphones will potential compromise with the federated learning. So here communication in in this type of networks can much more expensive, like to compare to the classical data center environments. In order to it will can fit the data generated by the devices in federated learning to develop the efficient method it for small messages to model updates for the training process. And second challenge is system heterogeneity. So many systems are connecting with the federated learning, like some different configuration systems are there, like different hardware, cpu, memory, different network connectivities, and different power like battery levels are connecting with here storage computational capabilities for each device in federated learning. It will may occur differ for the variability, and additionally network size, system related constraints. These are the constraints for challenges for the system heterogeneity, as well as statistical heterogeneity. It is also some data statistically changes here. So for example, mobile phone users have married vary usage language in context prediction level. So number of data points across devices may varying in the significantly. Privacy concerns. Here, finally, privacy concern, one of the privacy technique in federated learning. It is a major concern in federated learning application compared with the learning in the data centers. Federated learning protecting users data by federated learning can protecting the user data by sharing the model updates instead of the raw data. It can share the model updates only without sharing the raw data. Here, a very recent model to aim this privacy federated by using tools such secure very using tools such as a secure multi-party, where secure multi-party is a tool for the privacy preserving in federated learning. Poisoning. Data poisoning. So data poisoning is one of the challenge in federated learning. So data poisoning means so many different types of clients are participating in the contributing their devices for training data here. So different it is difficult to detect that malicious clients who are not authorized, and who are that malicious client for sending the malicious data or fake data for training this process, for poisoning this entire process model. This is a major challenge in the federated learning. Like say, similarly here model poisoning also. So many here here so many malicious clients can modify the received models like a tamper gradient and R parameters before sending back to the central server. They will poison this model entirely. So these two are the major challenges in the federated learning. Coming to some possible attacks about the federated learning. Some possible attacks like some reconstruction attack is the reconstruction attacks possible to happen in the federated learning. Like reconstruction attack means privacy leakage only not here. The privacy leakage will only not leak here, but also gradient client updates, like machine learning, k nearest neighbor. These all are the explicit feature values. Reconstruction attacks can be the privacy information of possible ways. Here, we will secure multi-party communication and homomorphic encryption to find against this type of attacks. Model inversion attacks. If the model can be queried many times, then the context level by the equation solving this attack. It can learn about the distribution of training data and the similar to this model. Like some other possible attacks will happen in the federating, like membership inference attacks, then attribute inference attacks, like some model poisoning attacks. The model poisoning attacks, it is a there are so many kinds of poisoning attacks, like such as a data flipping attack, backdoor attack. These are the main purpose of poisoning attack to affect the model performance without being noticed. It will attack on the performance of the model without being any noticed. So finally, we conclude about our topic. We'll introduce federated learning. It is for the solving the optimization problem in distribution machine learning. We'll introduce federated learning. It is a high privacy preserving technique to solve the optimization problems, and it can be user that it can be it can be motivated by the methodology that users that they can generate the locally central servers and but ratherly provide their computational power performance and local machine learning. So finally here, however, federated learning researchers can actively engage with the bringing new technology forward. Thank you, sir.